Equivalency statement here for millimeters and meters is that 1,000 millimeters is equal to 1 meter, right? Those are the same. 1,000 millimeters is the same as having 1 meter, right? It's the same thing. They are equivalent. So to convert 500 millimeters to meters, how do we do that? Okay, so I'm going to recommend first writing down what you start with. Right, so essentially you're going to write down 500 millimeters. That's what we start with. The next and most important thing is to set up your conversion factor. Right, so I always say this, that the units are the most important thing. Without the units, the number doesn't quite make sense. So we're going to focus on the units here. Right, so in order to set up a conversion factor and to do it effectively, what we want to do is we want the millimeters here to cancel out, and we want the desired unit to be what's left over when we cancel out. So how do we do that? So right now, our 500 millimeters is essentially in our numerator, right? That's the same thing as saying 500 over 1, right? So if we want millimeters to cancel out, we have to put millimeters on the bottom of our conversion factor, or the denominator, right? Meters is our desired unit, so that would go on top. The next step in our conversion factor and our conversion is to think about which unit is larger, right? The larger unit always gets the 1, right? So meters are larger than millimeters, so that's where our 1 goes. And then you're going to think about that conversion factor. How many millimeters are in a meter? Well, there's 1,000 millimeters in meters, so you put that 1,000 there. And then now we have our conversion set up. The rest is essentially just the calculator doing its work. You're going to multiply across and divide. So 500 times 1 divided by 1,000, and that gives us 0.500 meters. And that is our final answer. So 500 millimeters is equivalent to 0.5 meters, or half a meter. Let's look at another example. So let's say we wanted to convert 11 micrograms to milligrams. So micrograms are smaller than milligrams. You can confirm that. It's lower on our prefix chart. So we're converting to a larger unit. So when converting from one prefix to another, such as in this problem, it's easiest to convert through the base unit. So what does that mean? In this case, the base unit is the gram, right? If you look at your prefix chart, the gram is 10 to the 0 as its notation. So essentially, this is just a recommendation. You can do it in one step if that makes more sense to you. But we usually recommend doing this in 2 steps, converting through the base unit. So what we're going to do is we're going to do this in 2 steps. We're going to start out by writing what we're starting with, right? So that is that 11 micrograms. We're going to set up our conversion factor. So we want micrograms to cancel out. We're going to go 2 grams first, right? So micrograms goes on the bottom, so it can cancel out. Grams goes onto the top. That's our initially desired unit. Grams is the larger unit, so that gets the 1. There's 1 times 10 to the 6th micrograms in 1 gram. So that is your first conversion factor. Your second conversion factor would be going from grams to your desired unit, which is milligrams. So again, you want to set up your conversion factor so that what you're converting from cancels out and you're left with your desired unit. So we want those grams to be on the bottom, right? So grams is larger, so we're going to put the 1 there. And then we're going to put the 1,000 on the top because there's 1,000 milligrams in a gram. So again, now we have our conversion factor set up. The rest is essentially plugging it into your calculator, making sure not to make mistakes. You can double check that in your calculator. So we're going to multiply across and then divide, and that gives us a final answer of 1.1 times 10 to the negative 2 milligrams. So our equivalency statement here is that 11 micrograms is 1.1 times 10 to the negative 2 milligrams. Okay, so again, I can't stress this enough. Practice really does make perfect with this. So let's do these on our own. Let's try converting these and put your answer in the blue box. Keeping in mind that if you have any questions, make sure to write those down so that we can answer those in class. And there will also be those support videos to further help you with this. Okay, so let's talk about significant figures and why are they significant, pun intended. Okay, so when we use numbers in math class, those are considered to be exact numbers. These numbers are defined and not measured. When we do science, we usually measure things, right? When we measure things in science, they are not considered that precise, right? So what do I mean by that? We can only read our measuring instruments to a limited number of subdivisions. So we're limited by our ability to see smaller and smaller subdivisions, and we're limited by our ability to construct smaller and smaller subdivisions on our measuring devices. So therefore, although the actual measurement that you may get on something can be 12 inches, we cannot necessarily prove it to be so. Measurements do not produce perfect numbers. The only perfect numbers in science are defined numbers, such as conversion factors, in which we saw in the previous slide. So that is why we need significant figures. Okay, so let's go ahead and read this passage. And I would like you all to write down at least one important point from the reading on this slide, as well as from the last slide. So let's go ahead and look at these two tables. So the first table, we have pressure and volume of a gas sample and the calculated PV product. And then we have another table on the right. And this is the same data set, and now we're told that the measurements only have two significant figures, and all the numbers are therefore then rounded to two places. So let's think about this. What do you notice when you compare these two tables? So make sure to write down your answer in the blue box. Look at these two tables, compare them, and which one would be more useful? Okay, so significant figures. What are the rules for determining significant figures? Essentially, significant figures are all of those digits that we know with absolute certainty plus an estimated last digit. So significant figures provide essentially a system to keep track of the limits of our measurement. So to record a measurement, you write down all the digits actually measured, including measurements of 0, and you must not write down any digits not measured. When we do labs in person in class, we'll see what this actually means and those measuring devices and the limitations associated with them. So what do you need to remember about the above paragraph? Let's go ahead and think about that and write that down in the section below. Let's see some examples in the sketch above. The correct measurement is greater than 1.2 centimeters, but less than 1.3 centimeters. You can actually see that if you look at where that green strip ends. So it's between the two. It is proper to estimate one place beyond the calibrations of the measuring device or measuring instrument. So in this case, this ruler is calibrated to 0.1 centimeters, right? There's no lines other than those 0.1 centimeters. That is our calibration. So we can estimate the hundredth place. In this example, we estimate it to be 1.25 or 1.26 centimeters. So let's go ahead and think about this. Why can't we give the measurement of 1.255 centimeters? And again, remember, you can look back to those rules for determining significant figures. Go ahead and rewind to the previous slides and tell us or answer this question. So let's look at another example in the sketch above. It's apparent that in this case, it's pretty much 1 centimeter, right? So we know that the 10th place is 0. And we can estimate the 100th place to also be 0. So essentially this would be reported as 1.00 centimeters. It is vital that you include those in your reported measurements because these are measured places that are significant figures. Again, remember, our calibration for this device is 0.1 centimeters. That is why it's important. Why don't we give the measurement of 1.0 centimeters? Let's go ahead and answer that. All right, how would you report these two lengths? So let's go ahead and take a couple minutes and answer these two questions. So in all of the previous examples that we saw, the measurements indicate that the measuring instrument, in that case it was the ruler, has subdivisions of 1/10 of a centimeter. And that the 100th place is what's the estimated digit. There's some uncertainty about the last and only the last digit. The rest are known with absolute certainty. So in our system of writing measurements to show significant figures, we must distinguish between measured zeros and place-holding zeros. So what does that mean? We're going to talk about that in the next slide. So these are the rules for determining the number of significant figures. A, all non-zero digits are significant. So anything 1, 2, 3, 4, 5, those are all significant no matter what. All zeros between non-zero digits are also significant. So if you have, for example, 1, 0, 1, that 0 between those two non-zero numbers is also significant. All beginning zeros are not significant. So if that number starts with 0, 0, 0, all three of those zeros are not significant. Ending zeros are significant if the decimal point is written in, but not significant if the decimal point is an understood decimal. So what that means is that the decimal point is not written in. So we saw some examples of that. Sometimes they won't necessarily write a decimal at the end of a whole number, but it's understood that that decimal is there. All right, so let's go ahead and work on some problems. Use the rules on the last slide to identify the amount or number of significant figures in each of the following. And then let's go ahead and answer these as well. Remember, guys, practice really does make perfect. So let's go ahead and answer these as well. Keep in mind which ones you have difficulty with so that we can help you in class. All right, guys, so let's review all of those concepts that we've seen in this lesson. So we were able to convert between standard or expanded form into scientific notation. So let's go ahead and review that now. Let's convert the following numbers into proper scientific notation and then convert these numbers already in scientific notation into expanded form. And then let's go ahead and write how many significant figures are in each of the following. Again, remember you can rewind this video and go back to those rules. If it helps you, you can pause, rewind, fast forward. That's the advantage of this. Okay, so we made it. In conclusion, scientific notation, significant figures are concepts that we will be using for the rest of the school year. So it's really important to make sure that you are understanding them now. This is that foundational unit that will set us up for success for the rest of the school year. So scientific notation, significant figures, really, really important, along with conversions that we did, right? So make sure that you're always putting units, checking your answer for correct units, for correct scientific notation, and significant figures. So what do you need to remember about these in order to be successful for the rest of the school year? Let's go ahead and answer that. And in the next lesson, we will go ahead and move on to position and displacement. as well as speed and velocity, and look at how and why those are important.